Welcome back to Zenith Poker. Today we are continuing with our Foundations series with a video on range and distribution. Okay, so first up, a definition. So definition. We're going to first define what I mean when I say range, specifically hand range, right? So hand range. Okay, so hand range is a function, okay? So if you remember stuff from maths, we have a function. Let's call that function f. It doesn't really matter what the function name is, but let's call it f. And it maps from the set of all hands, right? Omega, right? So omega is a set of starting hands, and it maps from the set of starting hands to the set 0, 1, right? So the interval 0, 1. Okay. It is a function that takes any hand and maps it into this set. So let's say, for example, all right, so we see an example. Okay, so let's say we have an example. This function f maps the hand x as follows. Okay. Let's say it is 1 when we've got ace of spades, ace of diamonds, 0.5 when we've got king of spades, king of hearts, and let's say 0 otherwise. Okay, so that is an example of a hand range, right? So it's a function and it takes the inputs. It takes the inputs as a particular hand combination and it outputs a number, right? All it outputs is a number between 0 and 1. Okay. So what is the hand range when you're dealt a hand, right? So when you're dealt a hand, let's say we have the starting hand distribution. The starting hand distribution f of x is our function, and this is going to be equal to 1 for any hand, right? Okay. So basically any hand that you're dealt it with a number 1, right? This is the starting hand range. Okay. Now, one interesting thing that we can do with this particular type of function, the hand range function, is we can determine its size. Okay. So let's have a look and in another color. And we've got definition. Okay. So I've got definition for the size of the hand range. So the size of the hand range, we can call that the magnitude of f is simply equal to the sum of all possible hands in the starting hand range of f. Okay. And let's have an example of that. All right. So just looking at the size of the hand range. So as an example, let's go and have a look at this particular function here, right? So let's look at this function here. So it was one combo of aces and half a combo of kings, right? So then that would be, right, the size of that particular function, right, the size of that particular hand range would then be equal to 1, right, for the combination of aces that we've got, plus 0.5 for the combination of kings that we got, plus a whole bunch of zeros, right? Plus 0, plus 0, plus 0, etc. for all the other hands, okay? And that's just equal to 1.5, right? So there's 1.5 combos in that particular hand range, okay? So that is the size of that particular hand range. Okay, so given the fact that we know that there is, in fact, 1,326 different combinations, this means that the size of everyone's starting range is actually 1,326 combos, right? So the size of a hand range is the total number of combinations. Okay, let's move on. Let's get some space up here. All right, now let's think and talk about what we mean by a distribution. All right, so a distribution, right, another definition, right? So a hand distribution. This is a more important topic than the range, but we need the range to figure that out. So the hand distribution is a function. Let's call that function P. Function P, right, for which there exists a range F such that, right, P for there exists, sorry, other way around, there exists a range F such that P is equal to F over the size of F. So what does this mean, right? So the hand distribution is P, and the hand distribution is any function such that there exists a hand range such that the function itself, the hand distribution, is that particular function divided by the size of that range. Okay, so basically what this does is it takes the function f, right, and then divides it by the number of combos. So f of x, and if we divide that by the size of f, right, this is going to give us all of our p of x, right, by definition. Okay, so as an example, let's use this color. As an example, using that same range that we looked at previously, p of x, right, is now going to be 1 divided by 1.5 when you've got the aces, that particular combo of aces, and 0.5 divided by 1.5 when you've got that particular combo of kings, right? So that means it's 2/3 that combo of aces, so it's ace of spades, ace of diamonds, and 1/3 king of spades, king of hearts, right? And then 0 for any other hand, right? Okay, so basically all the difference between a distribution and the ranges is that the distribution takes the range and then it divides out the total number of combos, right? So it divides out the total number of combos. Takes whatever the range was, so it's a bunch of numbers, right? That tells you how many combos of each hand you've got, right? And then it divides out by the total number of combos. Okay, so if we go for another example. So for another example, in the starting hand range, right, you've got 1,326 combos. Then the starting distribution, right, P of X, is just going to be 1 over 1,326 for all X in the starting range, right? The starting set. So omega is the starting set. It's a list of all possible starting hands. Okay. So these two concepts are very important to understand, right? The range and the distribution. The range is something that you'll see talked about more often, but a lot of the time when we're talking about range, what we really want to know is the distribution. And the reason why the distribution is important is because with the distribution, okay, with that distribution P of X, we get one function that is in fact a probability mass function, right? So our distributions, hand distributions, in fact, probability mass functions. And what that means is that we can use probability theory to analyze our opponent's hand. Okay? So if we model our opponent's hand as a random variable, okay, and let's call it random variable X. So X is the random variable that represents our opponent's hand or our hand or something like that. Represents, let's say an unknown hand. Okay? But so even though we don't know what the hand is, we can have some information about that hand if we know the distribution. Okay? Because with this random variable, we can say that there is a particular distribution that represents or is the probability mass function for that particular hand, right? So P of X, that's the other way actually, probability that X equals X, okay? We have a probability mass function for this particular distribution. So let's have a look at an example of what I mean by this, okay? Let's say we look at the previous range I looked at with the aces and the kings, okay, as an example. So X is the random variable that represents that particular hand, okay? Now I can say that I've got a probability mass function P, right, or P subscript X, right? So this probability mass function is related to that particular random variable. Oftentimes I just remove this X because it doesn't really matter in terms of the context. P subscript X of, say, aces, right? Ace of spades, ace of diamonds, right? So I can input a particular combination into this distribution function and I get out the answer as a number, right? Here, for example, would be 2 over 3, a number that represents the probability that my opponent's hand is that combination. And this is useful for a whole bunch of mathematical reasoning that we'll use later on. For example, when we're calculating sort of stuff like expected value and whatnot, right? Okay, so I think we'll leave this video there. So there's quite a few things that we're going through with the range, and the distribution. So just a bit of a recap. The range is a function that maps the starting set of hands to the number 0, 1. So basically it tells us how many combos, how many combinations that we have of each particular possible starting hand. And it's basically a list of all possible starting hands with a number attached to it, which tells us how often that particular hand is in this particular hand range. And then the distribution basically just takes that hand range and divides it by the total number of combos. And because we've done that, we spit out a probability mass function which can be used to represent a hand in probabilistic math. Okay, so thanks for watching this video. Hopefully you guys learned something, and I will see you all in the next one. Bye now.